So we have seen quite a lot of biasing circuits for a common emitter amplifier. So 5 types of circuits we have seen. So the main reason why we need biasing is that we have to ensure that the Q point is always on the midpoint of the DC load line, which will ensure the transistor is operating always in the active region. And if the variation of Q point is there, either it will move upwards or downwards. So either it move towards saturation or cutoff. So the active region is going to be missed out, and the transistor can no longer be used as an amplifier. Okay, so that is the reason we stress upon all the biasing circuits, whatever we have studied, and we have derived the stability factors S, S dash, and S double dash for the circuits. And stability factor will give the numerical variation of the collector current with respect to the three temperature dependent parameters beta, VBE, and IC naught. So now we are going to see what is the common base amplifier. I told you we will be focusing only on common emitter, but there is some unique feature about common base amplifier stability. You know, in common base amplifier, the base is grounded, correct? So if this is going to be your transistor, in common base amplifier, the base is grounded. So emitter is going to be the input and collector is going to be the output. So this is the structure of a common base amplifier. So the three types of configurations, you know, common base, common emitter, and common collector. So common, next to whatever term you are going to come, that is going to be grounded. So base is grounded, input is emitter, output is collector. So this is the equation for common base amplifier current equation, IC equal to alpha into IE. Similarly, how you write for common emitter equation, IC is equal to beta into IB, right? So same way here, IC equal to alpha into IE. Alpha is the current gain plus IC naught. So when you find the stability factor, yes, S is DIC by DIC naught, you can see when you differentiate, you get the value as 1. I told you the stability factor value should be as low as possible. In common emitter amplifier, it was very high because this beta value is very, very high. But you see, in common base amplifier, the S value is going to be always equal to 1 or approximately equal to 1. So it is going to have the lowest value of stability factor always, which will ensure that your common base amplifier is very, very highly stable when compared to your common emitter configuration. So common emitter, since it is highly stable, there is no requirement for the biasing circuit to be designed for your common base amplifier because it is already stable. You need not add additional circuits to ensure stability of common base amplifier. I think what the point what I make here is clear. In common emitter amplifier, we derived the different stability factors S, S dash, and S double dash, and we made a statement that for the device to be thermally stable, the value of all these parameters S, S dash, and S double dash should be as small as possible. But in common base amplifier, that is not the case. The stability factor is approximately equal to 1 or it is in and around 1. So which says that the stability factor value is numerically very, very less. So the common base amplifier is going to be a very highly stable amplifier. It does not require any additional biasing circuit to fix the Q point in the center of the load. It will always be at the center. But what is the drawback? So why we are not using common base amplifier? We are using common emitter amplifier only everywhere. Since this beautiful property is there, right? The circuit is going to be highly stable. Then why we are not using common base amplifier in our applications? Can anybody say the answer? What is the reason we give so much importance to common emitter? And even though this common base is going to have a good stability, we are not going to use that. Why? What is the reason? Please think and say me the answer. Yes. What's the answer for that? What's the answer? Why we are not using common base? What is the current gain in common base? What is the value of alpha in common base amplifier? What is the range of alpha? What is the range of alpha in common base amplifier? Alpha is very much less than, alpha is close to 1. So there is no current gain in your common base amplifier. There is very good voltage gain, but there is no current gain. But in common emitter amplifier, you can have very high voltage gain as well as very high current gain, so which will eventually mean I'm going to have a very good power gain also. So even though my common base amplifier is going to be very highly stable, it does not require any biasing circuit for stabilization of Q point. It is not used practically because the current gain is almost unity. So the current amplification does not take place, only voltage amplification takes place inside the common base amplifier. Is that clear? The stability of common base amplifier is just a small topic to compare the stability of common emitter and common base amplifier.